Hello everybody. This is a quick video to wrap up the end of today's class notes. These are going to be the last 4 examples from the notes worksheet that we were working on today in class. So I'm going to start by talking about number 19. 19 says sine inverse of sine of pi over 3. In class today, we talked about how when we have sine inverse of sine, it only cancels right away if this function, or this angle specifically, is between negative pi over 2 and pi over 2. So I'm just going to put a little question mark and let's sketch it and see if it does fall in that range. So what we're saying is that that angle has to fall somewhere in quadrant 1 or quadrant 2. Let's see if that happens. From prior knowledge, I know that pi over 3 is located in quadrant 1. It's 60 degrees. So the answer is yes. So because pi over 3 falls within the acceptable range of inverse sine values, we can say cancel, cancel, and this does equal pi over 3. In class, I had a habit of double boxing the final answer, so you don't have to, but it kind of makes it stand out. Number 20 says cosine inverse of cosine of 4 pi divided by 3. Once again, it might be tempting to say that cosine inverse cancels with cosine, but we have to check first, does this angle fall into the acceptable range for cosine inverse? And in class we reviewed that it is 0 to pi, meaning I need to check, does this given angle, 4 pi over 3, fall somewhere from 0 to pi, or the upper half of the unit circle? Using our prior knowledge to sketch 4 pi over 3, if I think to myself this is 0 or 0 pi, over here would be 3 pi over 3. So 4 pi over 3 is past that by a whole number, a whole other pi over 3. So here's my complete angle. Here's 4 pi over 3. It's a positive angle, so I went counterclockwise. So our answer here is no. Need to keep going. So it's not automatically no solution or does not exist. It just means that it's not going to automatically cancel. We have some work to do. So let's get to it. This angle here, 4 pi over 3, from my prior knowledge, I know that the ordered pair on the unit circle at that location would be a short x, so negative 1/2, and a long y, negative root 3 over 2. And I was specifically asked to find the cosine of that angle. Cosine, when I'm on the unit circle, is the x-coordinate. So this now becomes cosine inverse of that x value, which is negative 1/2. So we successfully found cosine of 4 pi over 3, which is negative 1/2, and so my next step and my final step is I now have to ask myself, what is cosine inverse of negative 1/2? To do that, we're going to have to create a second sketch. And this question that we're on right now, this second part, goes back to what we actually already know how to do. So I'm going to ask myself, Didn't mean to change that color. Cosine inverse is giving me an x side length. So I'll write that as just a reminder. You don't need to if you don't need it, but if you do need the reminder, write it down. Specifically, a short x. I know that all cosine inverse angles must fall somewhere in the upper half of the unit circle. So if I see that I have a negative a half, that means that we went left a half, because a short x side length can either go right or go left. If it's negative, I have to go left. Negative a half is short, so it creates this angle with ordered pair negative 1/2 root 3 over 2. And if I check my ordered pair, x is negative 1/2, so I'm in good shape. And to finish, I just have to ask myself to actually do cosine inverse of negative 1/2. What angle is this? From my knowledge of the unit circle, I know the answer to that question is 2 pi over 3. And this is a situation where double boxing your final answer really does help this answer stand out amidst all of this work. If you're not sure how I knew that was 2 pi over 3, recall from our first unit circle knowledge, or initial knowledge, that any ordered pair that has 1/2 root 3 over 2 as the ordered pair on the unit circle is always associated with pi over 3 counts, or 60 degrees. In comparison, pi over 6 locations all the way around the unit circle is always connected to a root 3 over 2, comma, a half ordered pair. I can't help but just remind you that if you count by pi over 6, you will eventually get to something like 2 pi over 6. Well, 2 pi over 6 technically equals pi over 3. So just watch out for that. 20 is done. Let's now talk about 21, which says sine inverse of sine of 4 pi over 3. So these two inverse trig functions are technically exact opposites of each other, but before I can say they cancel, I have to see if 4 pi over 3 is between negative pi over 2 and pi over 2 on the unit circle. So let's sketch it. Once again, I know 0 pi is here. This is 3 pi over 3. So 4 pi over 3 is 60 degrees past that. So this angle is definitely not between. So here's pi over 2. Here's negative pi over 2. This angle is definitely outside of the right half of the unit circle. So it doesn't mean that I'm done, it just means I have to keep going. I can't say that these two cancel out, leaving 4 pi over 3 as an answer. Our ordered pair there is negative a half, negative root 3 over 2. And I'm asking myself, what is sine of 4 pi over 3? That will be the y value of this ordered pair. So this now becomes sine inverse of negative root 3 over 2. As soon as I see that I'm doing inverse sine, I know that that's giving me a y side length. I'm going to write that as a refresher. specifically a long y. So let's see if we can find the angle that is in either quadrant 1 or 4, because that's where inverse sine, the range of inverse sine is. If y is negative, that would be going down for a side length. So my ordered pair there is 1/2. I would go right 1/2 and then down negative root 3 over 2. And to finish this up, I just have to ask myself, what angle is that? Well, the fact that I went clockwise makes it negative, and that would be a negative pi over 3. And I'm done. My answer is negative pi over 3. Double box it, helps it stand out amidst the rest of your work. Last but not least, number 22 says cosine inverse of sine of 5 pi over 6. I'd ask that you press pause on this and work it out and see if we match. My hint will be find this first. Press pause. If you are now listening, I am assuming that we have done our absolute best to go start to finish on this question by ourselves. So let's see if we match. As a frame of reference, I know that this is 0 pi. If I'm counting in sixths, this is 6 pi over 6, which means 5 pi over 6 is 30 degrees short of the x-axis over here. So here's 5 pi over 6. The ordered pair there on the unit circle would be a long x, so negative root 3 over 2, up 1/2. Sine of that angle would be the y value. So this is now cosine inverse of 1/2. Cosine inverse gives me an x side length, in this case a short x. So now our job, just going to make it a little shorter, is to go find the angle that has a short x length of 1/2. That will put me in quadrant 1 because it's a positive x, so I go right 1/2. And that's a short x, so I go to the right only a little bit before going up. The ordered pair there on the unit circle is 1/2. Root 3 over 2. And I write the full ordered pair just out of good habit to say yes, that's where it is. And I just have to ask myself, what angle is that? The answer is pi over 3. So that was the last 4 examples from today's notes. And remember, homework tonight is the attached page, both sides. You can technically use your calculator to check your answers. Remember that you are not allowed to use your calculator when you're actually doing the questions, as all of these types of questions will fall on the no calculator section of the quiz. So when we quiz this, there will be a no calculator and a calculator section. Tomorrow we'll be learning how to do questions that actually require a calculator. So for emphasis, no calculator on the homework, but feel free to use your homework, your calculator to check answers. Make sure your calculator is in radians. Have a good night.